Good morning and good afternoon for some. Welcome again to Beyond Compliance. My name is Aaron Bolshaw with SafetyChain Software. I'm the moderator of Beyond Compliance. For those maybe joining us for the first time, this is a periodic industry update for process manufacturers. Our goal, very simple, to bring your insights around the market that shape the way we grow our businesses, deliver quality products to our customers, of course, mitigate supply chain risks, safeguard our brands, and all of this while we strive to improve yields and maximize productivity. And that's definitely what we're focusing on today, which is we're going to get into OEE and how to minimize downtime, max that performance out. And something that's very important to process manufacturers, especially when supply chains are super tight. We're still coming out of the pandemic a bit. We've got some new global conflict. So the sponsor, obviously, for Beyond Compliance is SafetyChain, which is the #1 plant management platform, uniting compliance, safety, quality, and the production side of the house. And we're scheduled here for about an hour. We are going to remain flexible with our time. So we may go the full hour, or we may, depending on how those questions go, end up with a few minutes back in our day. So first up, everyone's on mute. You can hear us, the presenters, but we can't hear you, but we do want to hear from you. So this is where we want to give you the instructions to use the webinar console on the right there of your screen to submit questions throughout the presentation. We'll save time toward the end of the presentation to get to as many of those as we can and to answer everyone's favorite question. Some of you are already asking. Yes, we will, everyone on the line will get the deck and the link to view this video after we're done today. So with that, it's my pleasure to introduce Vern Campbell to Beyond Compliance as our topic expert today. In addition to being a professional engineer, a master black belt as well, Mr. Campbell is the president of Process Management Consulting, 10 years at Manitoba Hydro. He's got the finance side, which is great when you kind of marry that with the operations side. You can get really great results when you kind of get the right KPIs. And then led their strategic planning and quality improvement initiative before assuming the GM role at Northern Blower. Very, very deep expertise in strategic planning and deployment, Lean Six Sigma training, coaching. He also has a data and analysis side of his brain. So you've got it all, and you've got a lot of really great background, especially academic-wise. Vern, welcome to Beyond Compliance.
Thank you, Aaron. It's a pleasure to be here today with you and everyone in the audience. I'm looking forward to our time together.
Yeah, good. We were just talking before we started the show. We just got word that one of our partners just sent all their suppliers a letter asking for help, just honest help, securing materials over the next 12 months, right? They had a detailed expectation that went out to their suppliers. Ultimately, this was to mitigate the disruptions they foresee coming from global conflicts. And now, right now, is as good a time as ever to focus on OEE. And Vern, really getting the most out of every hour, every pound of a material. Don't you agree?
I agree 100%, Aaron. The supply chains right now, I have the opportunity to interact with many organizations, and I know as many of the people out there are feeling the pain of supply. Their businesses are basically almost setting up 2 assembly lines, one to finish parts or components as far as they can, and then the next one to finish completely once they get supply in. So it's an ongoing issue, and really we can't afford not to be efficient and effective on this whole supply chain for our own collective benefit.
Yeah, I agree. Well, let's jump in. Before we get to the topic of the day, jumping into OEE, will you just give us kind of a overview of your organization, how you help manufacturers?
Certainly. My organization, our goal is to help organizations implement sustainable and I say advanced enterprise improvement systems. Basically, it's top to bottom, so that continuously improve SQ, CDME, safety, quality, cost, delivery, morale, and environment. So those high-level key performance indicators, with the goal being an operational excellence transformation and a transfer of knowledge so that the organizations become sustainable when it comes to continuous improvement. So that runs across all aspects, doing assessments, diagnostics, so we understand where to start. Very similar as what we're talking about with OEE, or we will talk about as a metric, but a diagnostic tool as well. Strategic planning, where do we need to focus on in order to help our organizations move forward, and then deploy that or cascade it throughout the organization. Process improvement, because ultimately our processes have to change. We have to innovate, develop new products. Ongoing daily management systems, the churning of the product, because we have to get the systems or the product out today, make payroll, but we also have to understand the problems we're facing so we can work to improve. And then fundamental to all this is leadership development and coaching, because leadership ends up being the core of the whole system. So that's just a little bit of background, Aaron, and I've worked, as mentioned earlier, across all different segments from manufacturing, mining, health, government, insurance organizations. So it's been, we're pretty broad, but the focus is on those transformations.
Yeah, good, very good. Lots of deep experience, so we're happy to have you here. The objectives, why don't you take us through objectives and then the agenda. The slides are yours, Vern. I'm looking forward to digging in with you.
Thank you, Aaron. All right, everybody. I'm looking forward to this. So I'm just going to provide, and the goal today is to introduce overall equipment effectiveness, or OEE, just as provide some background information and opportunities as far as how to get started. So we'll talk a little bit about the benefits of leveraging OEE, some thoughts about how you might get started or move forward with OEE, and some of the potential challenges and critical success factors moving forward.
Oh, one back there. Yeah.
There you go. Too anxious here.
No worries.
So an overview of the agenda, just a bit of background, purpose, and definition of OEE. The metric, how you go about calculating. We'll talk a little bit about what's coined as the 6 big losses that organizations look for and constitute waste when it comes to effectiveness and efficiency. How OEE, the losses, connect in with continuous improvement and start forming a foundation for focusing our continuous improvement efforts, going back to the supply chain challenges that Aaron mentioned. And certainly we know the challenges were tough prior to COVID or prior to the turmoil we're seeing in our supply chains right now. And obviously that's only grown exponentially. How OEE fits with our ongoing daily management or our daily operating system. So how does it connect into the ongoing work and operations we have? Some thoughts on how to get started, because the goal would be, and what I've always learned along the way is, my mentors would say, okay, this is great. Now, what are you doing tomorrow morning to start moving forward? So we'll talk a little bit about that and some of the typical challenges and potential critical success factors as far as moving forward with OEE, and then a wrap up.
Yeah, and we wanted to kind of start out really quick by a bit of a benchmarking study. So what we're going to do is we're going to launch a poll. So in front of everyone, real quick, you'll see this pull up. Excuse me. We want to ask a quick question about what you think your OEE performance is. So we're going to launch this poll. You're going to see it pop up in front of you in just a second. And we just want to know, answer honestly, we're not going to take names and show who you are or where you work or anything like that. We just want to know what best describes your OEE performance. Maybe you're looking at solutions. Maybe you're not using OEE, or you're starting to, which would typically say, hey, your scores are going to be up to that 40%. Maybe you're developing its use. You've had it for a while, but you're getting better at it, and that's going to be that 41 to 60%. There's others that should be in this operating stage where it's like, hey, we're looking at data, we're looking at the production schedule, we're looking at the OEE scores daily, you're operating it, and that's going to be that 61 to 80%. And anybody with an 80% or above is really starting to look at being more predictive in their operations. They're understanding where key bottlenecks are through that line or that process or that manufacturing facility. If you would just take a couple of seconds, we got 57% people voting so far, 60%, 62. And this is, again, this isn't meant to call anybody out and say, hey, where are you at and stuff. We just want to know, Vern and I want to know, hey, where we're at as far as our audience is concerned. So we got 2/3 now. I'm going to close the poll, and we're going to actually see the results here really quick in front of us, Vern. And anything on the results of this poll stand out to you?
It's an interesting distribution, and it's I think it's a nice mix in the group, and obviously with 7% of the people that are above 80%, that's outstanding, and 21% or 28% in total between 61 and over 80%. So very developing that maturity around OEE is fantastic, and other individuals, I guess the other 72% that responded, that are interested in learning, developing, and continuing to improve their operations. So it's a fantastic distribution, very interesting.
I think so too. I always think of that bell curve too. When you started saying that, I was like, yeah, it's almost a pretty good bell curve right there. So that's good. All right, well, let's move on. I think next up, you wanted to kind of get into sort of just the fundamentals, right?
That's correct. Thank you, Aaron. So we'll just talk a little bit about some of the fundamentals around OEE. And I like this quote from Jack Welch, former CEO of General Electric, who mentioned one of the challenges we collectively have is facing reality and then dealing with it. And when I talk to some organizations that are just starting out with OEE or have dipped a toe in the OEE pool, one of their comments was they got initial data, initial feedback, and their OEE score was embarrassing. So basically, they stopped doing it. And I like Welsh's comment that part of our job is let's face reality, where are we? And then now let's do something about it. So the purpose of the OEE metric is to systematically identify losses and waste and then improve performance over time. And this never ends, following the Plan, Do, Check, Act or the scientific problem solving method. I love Toyota and some other organizations that talk about the pursuit of perfection or pursuit of excellence. And that's the goal we're after. Some of the organizations I mentioned that get the OEE metric and then turn it off reminds me of an individual who's got a fantastic book, Katsuya Hasatani, who talks about the 4 types of problem solvers. One is the despairing type, who convince themselves they'll never solve complex problems. Another is a victim. It's always somebody else's fault. As we're maybe supply chain, instead of doing something, what can we do and work on our supply chain, as Aaron mentioned earlier? We choose not to. The ostrich, well, we look at the score, we don't like it, and we stick our head back in the sand and hopefully it'll go away. Not effective. And then the last that Hasatani talks about is the determined problem-solving individuals. And certainly having the courage to fight for excellence with operational or overall equipment effectiveness, or OEE, is critical. I just show this little equation, and many people have probably seen it before, where sales price minus cost is equal to our profit. And so the cost is, there's value add components in our cost structure, and there's waste or losses. So what we're talking about here with OEE is identifying those waste or losses, working to improve or reduce them so we can increase profitability, probably increase speed, and our overall effectiveness. Oops, sorry.
I can get you back there. Let me just pull me in if you need me. No worries.
Okay. I just want to give a quick little background, thanks, Aaron, of Nakajima in 1988-89. He did an awful lot of work around total productive maintenance, designed to maximize equipment effectiveness. Part of that or component, and probably the more advanced and maybe many organizations out there familiar with total productive maintenance, the autonomous maintenance of equipment by operators, getting small group activities, problem solving out in with our production group so that we can solve those problems. So something that Nakajima observed was production losses are combined with indirect hidden costs, and they make up a significant proportion of our total production costs. And I mentioned that that's going back to the costs in our product or our systems are value added, and there's waste. OEE, it's a measure, and this again goes back to Nakajima, a measure that attempts to reveal these hidden costs. So to take them from hidden so we can see them, and then we can do something with them. Just around that, just my own personal experience, I general managed a company called Northern Blower. I'm up in Winnipeg, Canada, just for anybody's reference. And we had the opportunity to work with Toyota's consulting arm for about 2 or 3 years that they came in and coached us. And one of the comments that the folks from Toyota gave to us, which was illuminating for me, is our problem wasn't solving problems. They said our biggest problem was seeing the waste and seeing the problems. And when we talk about hidden costs, that's what we're attempting to do. Make that waste and those hidden costs visible, so then we can start working on them. So again, just moving forward, OEE, definition of OEE, there's 3 components: availability, performance, and quality. And so it's a product of those 3 components. So in this particular example, availability, we have 90% availability, performance 95%, and quality is 80%. The product of 90 times 0.9 times 0.95 times 0.8 is 68%. So our OEE would equal 68. So just giving you a calculation and showing the 3 components. Availability, the definition of availability is what's our actual operating time, typically in minutes, over our planned operating time, again in minutes, times 100. Performance, what's our net operating rate times our operating speed rate times 100, and that'll give it to us, or a number in percent. Or simply, what's the actual output over a given period of time, say a shift or a day, compared to the theoretical output. And then the final is quality. So what was the total number of units we produced minus the number we scrapped or had to rework, and then that's divided by the total number produced times 100. So that's just a high-level definition of each of those components: availability, performance, and quality. So availability, just diving a little deeper into that. Again, what's our actual operating time over our planned operating time in minutes? So the actual operating time, the definition or the working definition, is equal to our planned operating time minus unplanned maintenance or downtime minus any minor stoppages that we might have, and then less any setup or changeover we have as well. So that would equal to our actual operating time. Planned operating time is our total shift time in minutes, typically less our planned maintenance. So if we have planned maintenance, what's our total shift time minus our planned maintenance, and that is our planned operating time. So just a little further working definition, and again, that doesn't mean your definitions may not vary. This is just one definition. And part of my research, when I've done research into OEE, there is variation in definitions. Organizations can have slightly different variations of these definitions. That's fine. Aaron mentioned my finance background. It's sort of like if you're looking at what's an organization's definition of net profit. It can vary from organization to organization, depending on that organization's definition of profit and what's included or not included. Performance efficiency. So a definition is what's the actual speed of the equipment over the ideal or standard specified speed of the equipment. Another slightly different definition is the net operating rate times the operating speed rate times 100. So the net operating rate is equal to how many units do we produce times the actual cycle time per unit divided by the operation time. And this calculation accounts for losses resulting from any minor recorded stoppages or unrecorded losses. Say if I'm running a lathe and I either slow the lathe down or I stop it to clear shavings out of the way, or whatever the case may be. Maybe a tool breaks and I need to replace the tool. This formula accounts for those minor stoppages. The operating speed rate is what's our theoretical cycle time divided by our actual cycle time. So again, just a different calculation of performance efficiency. Quality rate, the definition or the working definition of quality rate is the total number that we produced minus the number that were either scrapped or had to be reworked. Some organizations would call this what's our yield or first pass yield, and then we divide that by the total number produced and multiply that by 100. So basically, it's what was the yield of good units without rework divided by our total number we produced. So again, these are working definitions of the components when we're looking at availability, performance, and quality. Every organization needs to define these, and I'll talk about a little later. What is our definition of availability, performance, and quality? And then we need to define the data and be very careful about those data definitions as we include them into our indicator. It was interesting for me, and I'll talk about it in a little bit about maybe more detail. One of my roles when I was at Manitoba Hydro, I chaired a committee that was on performance evaluation. So it was a Canada-wide committee that developed common definitions on critical performance indicators across all utilities in Canada and were used to compare and benchmark across utilities. Something I found very interesting, a key indicator or metric around availability is related to how many outages a utility might have. Something I found very interesting in the utility I was with, Manitoba Hydro, definition was an outage was anything 60 seconds or greater. So if you're 59.99 seconds or less, that was not counted as an outage in our definition. Another utility, it was anything greater than 30 seconds was an outage. Anything 29.999 seconds or less was not counted as an outage. Another utility, it was 5 minutes. So anything greater than 5 minutes was an outage. Anything less than 5 minutes was not counted as an outage, which worked fine when you're comparing within your own organization year to year, as long as the definitions don't change. But it caused problems, obviously, when we were comparing across organizations. So again, it's just the importance of definitions, especially if you have multiple plants. We're collecting data that's defined the same so that we're comparing apples and apples, or maybe not even across plants, but across areas of your plant or equipment in your plant, whatever the case may be. 6 big losses. I just want to get into these. So again, we have our planned production time and then planned downtime. So 2 of the losses are equipment breakdowns, unplanned downtime, and setups and adjustments. So that's downtime, and when we take our planned production time less those losses, we get actual operating time. That gives us a high-level definition of availability. When we're looking at performance, idling or minor stops that I mentioned, or reduced speed that we're not operating or equipment's not operating, or if we're looking at a cell, the cell's not operating to planned speed. So those are performance losses or speed losses. So we have our actual operating time, less those become our net operating rate. Then we have quality losses, reduced yield at startup. Maybe in order to get, I have X percent of reworks just and adjustments just when I'm starting up a run on a piece of equipment before it reaches standard. That would be reduced yield at startup. Then as the equipment gets running, there may be defects or rework afterwards. So we have those quality losses. So reduced yield at startup and defects or rework when we get to operational speed. So net operating rate less our quality losses gives us our net value time. So those are defined as 6 big losses. And again, I know some places will talk about 7 losses, other places 8 losses. It's fine. What I just tend to find is OEE, like many things, unfortunately in business and operations, we start off with a good idea, and then if we're not careful, it tends to become overcomplicated. My preference is to keep things simple and workable. Just the losses defined, I talked about them a little bit, but just so you have for your reference, equipment breakdown, any unplanned downtime on equipment. And when I'm working with any organizations, and certainly as a focus in my career too, when I was operational, unplanned downtime on equipment, or unplanned downtime, again, if I'm looking at a cell that's operating. The goal is continuous flow. setups or adjustment times. This is the time lost from the end of the last item we produced to the start of production of the next item. Well, I haven't mentioned yet, but I also teach in the Faculty of Engineering at the University of Manitoba, and the engineers here work on real projects out in industry, and one of the project teams is working with a manufacturer, and this is exactly the waste they're focused on, is the downtime or the lost time from the end of one good item to the start of the next one. And they're digging into that loss because this is where the major lever is as far as the bottleneck point goes in that operation. Idling or minor stops, I mentioned that. Temporary machine problems, tools breaking, whatever the case, those things that just tend to happen when we're operating equipment. Or machines idling, maybe waiting for operators or whatever the case may be. Reduced speed, again, difference between the design speed and actual operating speed. And it's very interesting to me, and maybe my experience is unique, how often I go into organizations and I ask about the design speed of a piece of equipment, and many people don't know. They can't tell me what the actual design speed is. They just know what the operating speed is. So I find that curious. So that ends up being a bit of a light bulb for some people that, well, let's go back, let's check what the design speed is. And quite often, surprisingly, that ends up being one of those low-hanging fruits we just never knew. Reduced yield. I mentioned early stages from startup to we stabilize the production run and get it going, and then defects and rework, anything that doesn't meet spec. So that first pass yield. If we have to rework something, that is not part of our first pass yield. So again, going back to Nakajima, he just talked about OEE. It's a bottom-up approach, grassroots from the floor, where an integrated workforce strives to achieve OEE by working on and eliminating the causes of those 6 big losses.
All right, we're going to do another. Yeah. So thank you for that. You know, it's interesting. You talk about that design speed. A lot of assumptions start to creep into the processes, and it's just is one of those tribal knowledge problems that we all face in our facilities, right? Where we're handed this book of how to do the thing when you get the new job or you start to develop a new team, etc. And you assume, rightly, because you're just new, that how it's done is it's the best it can be because you trust the people that came before you. And often it takes just that inspection, like, hey, let's just take a look, you know? And so I already see some questions popping up about design speed that we'll catch later, Vern. So this is fascinating. Really quick, based on what we just saw, we're gonna do another poll question, Vern. So what we want to do is basically say, you know, again, same sort of scenario. We're not taking your name. We're not going to show your name, but I'd like to get everybody. Let's see if we can get 2/3 voting again. What do you suspect your most significant losses are coming from? And this is one of those that you can check multiple things, right? Equipment breakdowns, setup and adjustment time, idling or those minor stops, speed reductions, things like that. Maybe it's just reduced yield from defects or rework, or help, maybe like all of the above, which is okay. It's okay to admit these things, right? So, you know, this I would suspect this will be more all over the board, but we'll see. We got about 50% people voting, excuse me, so far. Go ahead, don't be shy. Click on that. It's okay, be truthful. We're not saying your names at all. So it does remind me of a story though. One of the SafetyChain customers who implemented our OEE solution very quickly learned that their assumptions, Vern, were very wrong about their T-max. And that's actually one of the questions I saw coming that later. And within about 2 weeks time, they were searching. They were like, I don't understand why, like, because they started to adjust the things, because you can see OEE in real time with SafetyChain. And in a matter of, I think it was either 2 or 3 weeks, they went and they reset their T-max, their theoretical max, and they improved almost 40%. So that's the power. You can make big leaps with solutions like this. I'm going to close the poll. We're going to share the results, and we'll see. Yeah, pretty good across the board. Love it. We're here to help. Vern's here to help. Vern, any thoughts? Any thoughts on this? Pretty equal across the board, huh?
Yeah, it's very interesting, right across the board. It's fairly typical of what I see, that many times in organizations, rework or defects is less, which is not unusual, because a lot of our efforts and quality assurance, quality control departments are very focused on that defect or rework rate. So to see that less than the others doesn't shock me. And so the others are very interesting, that they're relatively even. So I like what I see. It's very interesting and fairly typical, I think, too.
Yeah, what we find ourselves really promoting and coaching with our clients, Vern, as I'm sure you do, is really knowing this specifically, using data to your advantage to create an accurate reflection of what are those losses coming from, because the sort of quantitative method to deduction really helps speed up that improvement, right? Where because of data, hey, line 1, conveyor 2, let's say whatever, is slow to start, something's going wrong, maybe there's a maintenance issue, maybe there's some bearings, something like that. But when you see those trends through time, that's when, and it's a data trend, it's not like I think something's happening, when you show it in data, that's where you can really see and feel big time increases in productivity.
Oh, definitely, Aaron. And interestingly and coincidentally, this morning, a steel mill I was doing some work with, they just sent me some of those charts showing the improvements they've made over time. And they were just giddy about what they were seeing by focusing on those improvements. So that data is magical.
That's fantastic. All right, let's get going on. We do, oops, sorry, I pushed you forward there. We do tend to get the question almost right after any of these, Vern, well, where should I be? Where's the benchmark? Why don't you take us through some of this?
Certainly. Thanks, Aaron. Well, I just, if we start off, just as we're starting to develop, starting out, typically OEE might be 40% or so, or less. And then as we move forward and we start working, consciously working, as Aaron mentioned, using facts, using data, and starting to diligently improve our operation, we might move from 40 to 60%. And then again, as the inertia or the flywheel keeps turning, then we move 60 to 75%. We're still working, identifying the waste, developing our capability to both see and address the waste, but it gets harder because the waste is harder to get at root cause. So we move from 60 to 75%, and then typically world-class, right now anyways, is deemed to be in around 85%. The improvement in time curve along underneath those numbers indicates just how, as you go forward, the effort becomes greater in order to get incremental improvements. And I'm not sure how many people golf, but I golf. And I see a lot of similarities. When you start off reducing your handicap, maybe you can cut, I don't know, 5 or so strokes off your handicap fairly easily. But if we take that to world class and look at the professional golfers, getting a small incremental improvement is much more difficult. And that's sort of the progression on OEE, going from my golf analogy, I'm a weekend duffer, to the pros on the tour. It takes an awful lot of effort, a lot of data, and a lot of work to improve. And when I'm doing this stuff, I love golf, but I think there's so many analogies. I say most people doing improvement should golf as well, because then you really get a feel of it. Just some of the aspects about getting started. Critical to any of this is senior management. I think senior managers need to be educated and committed that we're going to move forward with OEE. We're going to move forward with improving our operations, recognizing that the initial score might be not very pretty, but it is what it is. That Jack Welch saying, let's face reality, get on with it. So I think it's important, focus on the purpose. The purpose is improvement. How do we improve performance versus using OEE as a score? It is a score, but it's a monitoring score, sort of like, again, my golf score. It monitors how I'm doing in the game. If I'm going to improve my golf score, I need to work on my game. So we need to focus on what's our purpose. Our purpose is improvement. Start small. Zarin mentioned focus on the pain point. Where can we start? Where's it painful? Now let's get in and start there. Overall, we need to communicate, engage everybody in the game, eventually. Again, start small. Later on, I mentioned pilots. Find a pilot area, work there. I'll mention, and I'll just give a quick overview of daily management systems, but it's how do we every day identify problems so that we can work on problems to improve daily. Obviously, if we're going to solve problems using data, we need to develop those problem-solving capabilities and competencies at all levels. I mentioned paying attention to definitions and data collection systems. Data is a representation of facts, so we need to know what we're working with. And another just point that I like, it's progress, not perfection. We're striving for perfection, we'll never get there. The goal is progress. Let's start, let's learn, and let's improve.
Yep.
So I just quickly, current situation, wherever we are, what's our target? And it could be, if my current is, let's say 40% OEE, target 60%, looking at those 6 big losses, where am I going to work? What am I going to work on to improve? And blowing it down to one problem at a time, one loss at a time. And let's focus. And the little cycles there are just plan, do, check, act, scientific problem solving wheels to move us from our current situation to that target condition. This might be a little overwhelming, and certainly forgive me, please, but I find it useful. You'll get the slides over time. Hopefully you can digest it. I'm just going to focus on the green box here, which is the daily management system. So like any organization, we start with standards, equipment speeds, operations, materials, whatever the case may be. And we run our operation through the day or through the hour, whatever our time frame is, following the standardized do, check, act cycle. So we work on that. And from our operation, which could be every hour or every day, and I recommend small cycles, small time cycles, we identify problems. Simple problems or minor problems, we work to improve following the plan, do, check, act, problem solving method. And typically this will be closer to those frontline people, maybe a team lead, working with frontline people to find opportunities to improve and enhance our new standard. And it could be something as simple as we're not running the equipment at the theoretical max operating speed. Okay, let's test that out. Will it work? Okay, that becomes our new standard. And now we work that into our new operating daily management system. And we continue to do that. We might see broader themes. This could be unplanned breakdowns. Maybe our preventative maintenance system or predictive maintenance system isn't operating the way it should be. This might become more of a strategic improvement. So this is a really good model that I have found. So like I mentioned, I would encourage people to study this. Source, Kansai Electric. I was introduced to it. I've had the great fortune to go to Japan a few times and visit some very good companies and the executives of some very good companies to talk with. And Dr. Noriaki Kano, some people may have heard of Dr. Kano. He's probably one of the leading people in the world when it comes to organizational improvement, or as folks from Japan call it, total quality management. I just want to introduce this quickly. This is a little Six Sigma type graphic, but I find it useful when I'm looking at improvement. Thinking about across the center is SIPOC. It's an acronym for suppliers, inputs, process, output, customer. So our output going to our customer, this could be our OEE as being one of our key metrics for identifying how the process and inputs are operating. Within this, we have process losses and we potentially have input losses. So OEE at a high level is a function of potentially input losses and process losses. So this little graphic could become part of our analytical framework if I'm looking at a category of unplanned downtime. Okay, let's look at what are the process components or losses that are contributing to unplanned downtime and what are potential inputs that are contributing to that unplanned downtime. There's a lot of information flying at everybody, but I learned to give people information from a fire hose, and hopefully something will be useful. 7-step problem solving method. I talked about problem solving being a core competency. This is a classic scientific problem solving method adapted from Dr. Kume. So basically define the problem using facts and data. The definition of a problem, or my working definition, is a fact or database gap between current performance and standard or current performance and desired. Then we observe the problem. We go investigate. We start asking ourselves, what's happening? Where is it happening? When's it happening? Who's it happening to or by? And Aaron, you mentioned a little bit of that, narrowing it down to maybe a particular line or a shift, potentially. Then we do our analysis. What are the causes? So the causes of potentially unplanned downtime. Let's identify those causes and start potentially developing a theory around root cause. Then we go and we act. We take action to work on those root causes to improve performance. We check our results. If we demonstrate that the change is in fact an improvement, that becomes part of our new standard, and we integrate it and build it into that daily management system we talked about and control it. And then we draw conclusions. Where do we go from here? What's the next problem or next loss we're going to work on to improve our OEE? Tools are useful. These are just a couple simple tools. And again, some people might be aware of them. They're part of what are called the 7 QC or quality control tools. The one on the left is called a cause and effect diagram. Another name for it's a fishbone diagram because it looks like a fish. Or the third name is Ishikawa diagram after Dr. Ishikawa, who was quote unquote the inventor of this tool. Very useful when we're looking at a loss, say unplanned downtime, operating speed, quality, reworks, what are all the potential causes that could be contributing to that? Then we can go investigate. A great tool for involving frontline people and getting a lot of people engaged in working with us. The second chart, a Pareto diagram. This is an actual case that I'm working with an organization right now. They're looking at reworks, and what they've identified is one category. So in this particular case, it's called LOVAX. So it's a food processing organization. They're identifying LOVAX, or the major category defects that they're going to work with. So again, that gives us focus. We look at quality as one of our big losses. Now they've narrowed that down to LOVAX, and now they're focused on what's going on in this LOVAC, a particular part of their line. So I just want to summarize. I realize time is getting tight here. Some of the critical success factors: OEE, the purpose of OEE, systematically identify losses, waste, and improve performance over time following Plan, Do, Check, Act. So again, it's a monitoring metric Aaron mentioned, so we can see with facts and data our rate of improvement over time. Getting started, I recommend start small, but get started. An individual I studied, learned from my mentors, was Dr. W. Edwards Deming. And Dr. Deming, one of his comments was, I don't care where you start, but start. And so I think just getting going. Manage the people side. A lot of this is change management. So communication of what are we doing? Why are we doing this? How are we doing this? And as Nakajima mentioned, core to success is developing a favorable work environment in his terms. Integrate with our other systems. And then something that's been with me for my, God only knows how many years my career, all this takes patience, passion, perseverance, and you do have to be resilient, as we all know right now. So just a couple of concluding marks and wrap up. Senior management commitment to OEE as a strategic key performance indicator. It's a metric. We need to define it, trust it, and monitor it. Focus on improvement and process, not on blaming people. So this is getting into definition of losses and collecting data and getting at root cause using facts and data. Develop robust data definitions and collection systems. That data integrity is critical. We need to trust the data. Daily management systems I mentioned, so that we can see problems and we can integrate problems into new standards. Developing that fact and database problem solving competency at all levels, starting small, focus on the pain point, getting started. Quick wins so that we can learn and grow our capability. And as I mentioned, pilots are always a good idea. And I talked again, the last point, patience, passion, perseverance, and resilience. Bob Rotella, sports psychologist, wrote a book called Golf is Not a Game of Perfect. In there, he made the comment, a commitment to improvement's not a casual thing. So it's hard work.
Yeah.
So I'll leave it with that, Aaron. I've gone a little bit over time and I apologize for that.
No. I think we're right on time. We just got a couple of questions. I wanted to back up really quick because you showed something, and this is when we get excited at SafetyChain, because this kind of visibility to what's really going on, the ability for you to take data, visualize it so that you can act on it quicker, is a really key piece of this. And what we find with our customers, Vern, is that in general, your more world-class OEE performers, the ones with you think of it, the big shot, they got it all figured out. They didn't have it figured out when they started, and they got there slowly through things like this. And what we do is we enable process manufacturers to see this kind of information in real time, and that changes the game. It really actually starts to make teams, whether it's your safety and quality team and your production team or your maintenance team, work together, because they
Yes.
see, you see what's happening down the line or up the line, and you're like, oh, I get it now, right? So the visibility across the line and across the teams in real time, very, very critical. And I'm looking at your Pareto chart and I'm like, oh, I think I know who this is. So very fun, very good. Listen, do have a couple of questions. I want to make sure that we get to your information so that people can see this while we go through them. A little bit earlier, Vern, you talked about design speed, and I said, hey, somebody just piped in with a question, and they had a couple of them. So the first one was, how did you go and inspect what the design speed was? Can you take, if you can, was that a manual? Was that a equipment manual or something? How did you find the design speed or go challenge that?
Our first point that I find with organizations and myself personally, we first went to the operating manual. What's the operating manual tell us?
Yep.
And then if we didn't find the information we needed then, what we also did, and it seems obvious, we went back to the original manufacturer and talked to the manufacturing rep and involved their experience and helping us and working with us get our equipment set up so it performs to spec and to that theoretical speed that we were quoted. Because it was interesting, quite often you make your purchase decision around that theoretical speed. Yep. And then what I see is often it gets implemented, and that it never gets passed along through to the operations for whatever reason. So it seems obvious in hindsight, but operating manuals and then getting back to the old OEMs or the equipment manufacturers and involving their experts in working with us on that speed. That was my experience, Aaron. I'm not sure if you've had other experiences or what you found.
That's precisely it. Sometimes we find that some of our equipment is, we can't find those manuals. You go back to the manufacturer. In some rare cases, when you go to and you find, and it's just a dead end, you have to just start to look at how old is the machinery, what's the wear and tear, because some of the machines, it's like any machine, it's not going to go as fast. Mm-hmm. So it's not going to be able to keep up the speed. So then you kind of go to those the maintenance logs, and you have to define it in a metric in some way so that you can start to progress from there. Sometimes we've heard some pretty creative ways of getting that design speed or that theoretical max, but ultimately getting to a number that you agree to is the step that you're trying to get. Don't forget that. Don't just get wound up on where's the manual. And then the next question here was about that, like, hey, so we've got three. I'm oversimplifying this. This is kind of a big question, so bear with me, Vern. They've got several machines, sort of, they link lines down the line. There's this one machine, there's this other machine, this other machine. The question was, on the design speed, do you want to find the speed for the whole line or the individual machines, right? Like, how do you really create the best view of what that theoretical max is? Is it per machine or is it per line, right?
My answer, that's a big question, you're right. My answer off the top of my head is you need both, which is sort of like the economist, it depends. But I think we need to understand what is the theoretical max operating speed on each piece of equipment. If it's a continuous flow, then we're bottlenecked by the slower speed piece of equipment, and that sets the pace for the line. Then it potentially working, like you were saying, Aaron, can we start doing a little bit of experiments, maybe with our engineering group, internal engineering, maybe our maintenance people, or maybe potentially the supplier, to start moving that bottleneck point up slightly so we can increase the pace or the speed of the line itself. So
Perfect.
it's that theory of constraints idea as we're looking at a line.
Yep. Good. And one last one, Shaylee, you've been patient. Shaylee asks, with the question, you can't plan a changeover that won't affect OEE. So there's kind of a question in the statement there. And I'll rephrase it. Can you plan a changeover that doesn't affect your OEE?
Well, I think changeovers are always going to, my view would be changeovers are always going to affect OEE. But part of it is if your current changeover is 4 hours, can we get it down to 15 minutes? So it has less impact on that change or on OEE. Mm-hmm. So many organizations I work with right now, you think, the analogy often used is a pit stop at NASCAR or Formula racing versus me changing a tire on the side of a highway. So how do we move our changeovers, identify the losses, and speed those up? And I'm working with an organization right now. That's the whole goal is changeovers and the speed of changeover. And it's quite often it starts by seeing it, even asking that question, and not accepting the current pace is what it needs to be. It's how do we cut it by 50%? I don't think you'll ever get to zero, but we can get, anybody familiar with single minute exchange of dies? There's a lot of information there around how we can eliminate the waste or reduce the waste of our changeovers.
Yeah, I'd add one.
Aaron?
Oh, so sorry about that. Go ahead.
No, I just said your thoughts, Aaron. Sorry, I was asking you.
I would just add one thing to that. We've found also quick hits. If you are looking at changeovers and you're like, hey, you're having troubles, if you've got multiple shifts and your changeover times are varied between those shifts, go talk to your high performer. We found in a lot of instances some individuals that do some pre-changeover setup that makes it quick, easy. We got stuff right there. And it's all it is just somebody thinking, planning ahead, getting everything prepared so that when you shut the line down, you're like you said, it's that formula or that NASCAR pit stop. You got everything up, down, back on the line. So look for bright spots. Who's doing it well? Go ask them what they're doing. Go watch what they're doing. They'll know. They're experts. They want to do this right. So there's experts on your team, I promise you. A couple of things coming up, Vern. Because we're a little over time, optimizing your CAPAs. We're going to be with the Atchison Group on next Friday. So for FSMA Friday, RCA's CAPAs, and then going already into Q2, April, measuring the real cost of quality methods, models, and tips. We're going to get into the real cost of that quality. So lots more to find, and go to SafetyChain.com if you want anything else. That's it though, Vern. I really appreciate you taking some time of your day, talking with good people in our that frequent beyond compliance, and even the folks that are new. And I appreciate all of your wisdom.
Thank you very much, Aaron. I'd like to thank everybody for attending. Hopefully we've added some value over the past hour to help you out.
Absolutely. Thank you so much, Vern. That'll wrap it up for us here. Beyond Compliance. Go out there. Be productive, and have yourself a great day. Thank you so much.
Thank you, everyone.